We use kinematic equations to describe the motion of objects whose acceleration is not changing. These equations illustrate the relationships that exist among displacement, velocity, and acceleration. This equation for average velocity and this equation for acceleration apply to objects that are undergoing uniform or constant acceleration. Zero acceleration is also considered uniform acceleration. We will use these two equations to derive another equation for uniform acceleration. First, we will solve the average velocity equation for displacement. Since we're dealing with linear motion or motion in one dimension, we'll leave off the vector arrows in our expressions and use positive and negative signs to indicate direction. If acceleration is uniform, then the average velocity equals the initial velocity plus the final velocity divided by 2. Plugging in our average velocity expression into our displacement gives us this new expression for displacement. This equation is the first of 5 kinematic equations we can use to describe and solve for motion in one dimension that involves uniform acceleration. These 5 kinematic equations will help you to solve physics problems involving uniform linear acceleration. The kinematic equations involve displacement, acceleration, final velocity, initial velocity, and time. As you can see, each equation only involves 4 of these. When working a linear kinematics problem, be sure to write down what you are given in the problem and what you are looking for. Then select the kinematic equation or equations that contain your knowns and unknowns. Let's do an example problem. I accelerate my motorboat from 7 meters per second to 13 meters per second at a rate of 0.6 meters per second squared. How far does the boat travel? Consider forward to be positive. First, let's draw a picture, me in my motorboat, with an initial velocity of v1 and a final velocity of v2. What known values are we given? My initial velocity, v1, is 7 meters per second. My final velocity, v2, is 13 meters per second, and my acceleration is 0.6 meters per second squared. And what are we looking for? How far does the boat travel? That's the displacement. Looking at our table of kinematic equations, we find that this equation contains our knowns and unknown values. Next, since we're looking for the displacement, we will solve our equation for displacement. Then we plug in the values that we have into this equation. And finally, we use our calculator to solve, getting a displacement of 100 meters. So my boat traveled 100 meters as its velocity changed from 7 to 13 meters per second at that rate of acceleration. Remember, when you're working kinematics problems, write down your known and unknown values. Then check the table of kinematic equations to see which ones contain your knowns and unknowns.